You know that classic sci-fi dream, right? These tiny microscopic robots swimming through your body, fixing cells, fighting off diseases? For the longest time, that's all it was, pure science fiction. But that is all starting to change in some really, really mind-blowing ways. I mean, for decades, our whole idea of this technology came from movies like Fantastic Voyage. You had this tiny submarine navigating the bloodstream. It was such a cool fantasy, and it was kind of a North Star for researchers. But let's be honest, for a very long time, that's all it was, a fantasy. Well, now fiction is officially meeting fact. Just listen to this quote from lead researcher Mark Miskin. He says his team has created autonomous robots 10,000 times smaller than what's come before. That isn't just a small step forward. That's a giant leap into a completely new world. And that breakthrough is exactly what we're going to dive into today, the world's first ever truly autonomous, programmable swimming microrobots. To even begin to wrap our heads around this, we have to start with just how ridiculously small they are. Okay, so we're talking about machines that are about 250 micrometers long. Now, what does that even mean? Well, picture a single grain of salt. These robots are smaller than that. They're roughly the size of a paramecium. And these tiny little specks are fully functional robots. It's incredible. So you have to wonder, why did this take so long? Well, it turns out building something this small isn't just a tough engineering challenge. It's a physics problem. Because at this scale, the laws of physics as we experience them basically get turned on their head. The microworld plays by a totally different set of rules. The researchers had this perfect analogy to explain the challenge. See, for us, when we swim, momentum is our friend. It carries us through the water. But for a microrobot, water is so incredibly thick and sticky that it's like trying to swim through tar. Seriously. At that tiny scale, drag wins every time. So all the normal ways of moving, propellers, flippers, they're completely useless. And of course, a breakthrough like this didn't just happen overnight. This journey really kicked off all the way back in 1959 with a visionary lecture by the physicist Richard Feynman. It took decades, literally decades, of slow, painstaking progress in robotics and nanofabrication to finally make that vision a reality. So how did they finally crack the code? How'd they solve this whole swimming through tar problem? Well, they had to invent a completely new kind of robot, one designed from the ground up to not just survive, but to actually thrive in the bizarre physics of the microworld. And this is where the design is just pure genius. For propulsion, forget moving parts. Instead, they create what they call an invisible river of ions that literally pushes the robot along. For power, tiny little solar cells just sip enough energy from light. The brains are a tiny chip with just 128 bits of memory. That's it. And for communication, get this, they do a little waggle dance, wiggling in specific patterns to send data. Now, the absolute key to making this whole thing work is its unbelievable energy efficiency. These little robots run on just 75 nanowatts of power. To put that in perspective, that's over 100,000 times less power than a smartwatch. This is what lets them be truly autonomous, powered by nothing more than a little bit of light. And here's the other game changer. Because they're built using the same technology used for computer chips, they could one day be mass-produced for less than a penny a piece. Think about that for a second. This isn't about building one precious, expensive robot. It's about unleashing disposable swarms of millions of them. It's a totally new way of thinking about robotics. Okay, so we've got these tiny, autonomous, programmable robots that we can make for practically nothing. What can we actually do with them? This is where the possibilities start to sound like they're pulled straight out of a sci-fi movie. I mean, just imagine swarms of these things monitoring our health from inside our bodies, right at the cellular level, or delivering a drug directly to one cancer cell and leaving all the healthy cells alone. They could be used to build brand new micromaterials from the bottom up, or to sense pollutants in super fragile ecosystems. They can even detect tiny temperature changes in our cells, which could completely revolutionize how we diagnose diseases. Of course, we gotta pump the brakes a little. We're not quite there yet. The researchers themselves are the first to say that while this is a massive leap forward, there are still some major hurdles to clear before these robots can really leave the lab. For instance, right now they're operating in clean fluids on a flat 2D surface. Navigating the messy, complex 3D world of, say, the human bloodstream is a much, much bigger challenge. We have to make sure they're completely safe and biocompatible. We need to figure out new ways to power them deep inside the body, away from any light source. And of course, we need to keep shrinking their sensors and memory to make them even smarter. But let's not lose sight of the core breakthrough here. As Mark Miskin puts it, this isn't just about a better microbe robot. This unlocks an entirely new scale for programmable machines. This is a truly foundational technology we're talking about, a real building block for the future. So we end on this thought. For the very first time, we have the tools to build autonomous machines at the exact same scale as the biological cells they might one day help. We've basically opened a door to a whole new world. And the only question left is, what do we build first?